Hello friends, welcome back to my channel. So in this tutorial we'll look at this question: how do you solve this integral? So how I would solve this integral, I'm going to start off by using a u-sub. So by doing a u-sub, I'm going to let u to be equal to negative natural logarithm of cosine of x, like this. So I'm going to do the change in limits. When x is equal to 0, we have u to be equal to negative natural logarithm of the cosine of 0 is 1. So cosine of 0 is 1, and then natural log of 1 is 0. So that's going to be 0. When x is equal to pi over 3, that is the upper limit, we have u to be equal to the negative ln of the cosine of pi over 3. Cosine of pi over 3 is cosine of 60, which is half. And that is really what negative ln of 1 minus ln of 2. And that is going to be ln of 2. So our limits will change from 0 to ln of 2. So because ln of 1 is 0, and then we have 0 minus ln of 2, which is negative ln of 2 times negative, so positive. So let's find an expression for dx. dx is going to be negative. Differentiating this is going to be 1 over cosine. Then you differentiate cosine, which is negative sine of x. So that is really positive sine of x over cosine of x. And that is tangent of x. So du is going to be tan of x dx. So we have an expression for dx. Now we can take our integral really round from the x world into the u world. So that's going to be the integral from 0 to the ln of 2 of 1 all over ln raised to the power 4. So that is 4 of that. So that is going to be 4 of them, but u was equal to negative. So if we are raising to the power of 4, that is going to give you positive ln raised to the power 4 of cosine of x. So this is really u raised to the power 4 minus 1. And then dx is going to be tan of x dx. And then tan of x dx, we are going to replace that with du. So our integral is now something familiar. So this, you can use partial fraction to split this one down. This one is going to be 1 all over u raised to the power 4 minus 1 du. And that is going to be the integral from 0 to the ln of 2 of 1 all over u squared minus 1 all over u squared plus 1, all this one du. But we have to multiply by 1/2. And this is how this one can be split. So we can really do something here real quick. So this one, 1 all over u squared minus 1 all over u squared plus 1. This the LCM is u to the 4 minus 1. So this we really have u squared plus 1 minus u squared minus 1. And that is really 2 in the numerator divided by u to the 4 minus 1. So in order to cancel out this 2, we have to divide by 2 or multiply by half. That is what we have here. So that is how this one can be split. And now our integral is now the integral 1/2 from 0 to ln of 2 of 1 all over u squared minus 1 du. All this is multiplied by 1/2 minus the integral from 0 to ln of 2 of 1 all over u squared plus 1 du. All multiplied by 1/2 in front. And then this one is 1/2. This one can also write this one as negative, the integral from 0 to ln of 2 of 1 all over 1 minus u squared du minus the integral from 0 to ln of 2 of 1 all over u squared plus 1 du. And if we know this is the tan hyperbolic inverse, and this one is the tan inverse, so or the arctan. So that is 1/2 negative tan hyperbolic inverse of u. And we're integrating that from 0 to the ln of 2 minus this one is the tan inverse. That is the tan inverse of x u. And we are integrating that from 0 to the ln of 2 like that. Okay, but we know that the ln of tan hyperbolic inverse of u is the same as 1/2 the ln of 1 plus u all over 1 minus u. So we can plug that into our integral, and that is going to reduce to what? That is going to be 1/2 negative 1/2 ln of 1 plus u all over 1 minus u. From 0 to ln of 2, we are not putting in our limits yet, minus the tan inverse of u from 0 to ln of 2. We can now distribute our half in, and that is going to be 1/4 negative ln of 1 plus u over 1 minus u minus 1/2 tan inverse of u from 0 to ln of 2. So 0 to ln of 2. But this one is 1/4 ln of 1 minus u over 1 plus u. That is bringing the negative all the way to the power and then switching the fractions. So from 0 to the ln of 2 minus 1/2 tan inverse of u from 0 to ln of 2. Okay, sweet, nice and sweet. So we can now plug in our limits. So that's going to be 1/4 ln of 1 minus ln of 2 all over 1 plus ln of 2 minus 1/4 ln of plug in 0, 1 minus 0 over 1 plus 0 minus 1/2 tan inverse of ln of 2 minus 1/2 tan inverse of 0. So that is going to be 1/4 ln of 1 minus ln of 2 all over 1 plus ln of 2. This is ln of 1 because 1 over 1 is 1, and then ln of 1 is 0. So minus 1/2 tan inverse of ln of 2. And this tan inverse of 0 is 0. So this is how our integral can really be simplified. So therefore, the integral from 0 to pi over 3 of tan of x divided by ln to the 4th power of cosine of x, like this, minus 1 dx. This one really simplifies to 1/4 ln of 1 minus the ln of 2 all over 1 plus the ln of 2 minus 1/2 tan inverse of the ln of 2. So this is the value of our beautiful integral. So if you really find this helpful, make sure to smash the subscribe button for more engaging tutorial on integral calculus. So I thank you so much for watching this video, and I will see you in the next one. Bye bye.